Started. Beforehand, does anyone actually have any professional or academic experience in applied category theory? No. Me neither. Basically, I'm going to give you a talk on the first 10 years of my career and why I wish everyone got trained to enlist before moving on to the reality that we live in, and a couple of ways that you can use psychology to communicate your concepts. We're talking a lot about technical debt because you're all Kubernetes engineers and you've got incredible amounts of technical debt. If you want to follow these slides, you can do so there, but I'm happy to send or communicate with all of you as we go. You know what, I'm just gonna, there we go. Okay, so here's what we're gonna cover today. I'm gonna explain to you why we're using the turtles metaphor, and then we're gonna talk about abstractions as a team intelligence. I have to say, every time I go to a Kubernetes anything, I hear more about psychology and your ability to observe and understand and communicate your systems than I hear about tech. And I'd really like for that to change. My background and why I am qualified to talk to you, no, I do not sit and write monads all day, although in some ways we all do. My background is as a signal processing engineer. I was working on scalable computing projects. I was one of those individuals mentioned in the keynote that went for a PhD and got recruited directly into the Missile Defense Agency. When I say I build large, scalable products with beautiful blank checks attached to them, I have to do so in environments where we cannot fail. So I'm trying to create conditions where our fitness functions are actually discrete. And lastly, I'm really concerned about security in this area because now I work as a cybersecurity engineer. I'm currently working as a director of cybersecurity, and I intake Kubernetes projects. I intake projects from CNCF. And that means that if 9 out of 10 of your lines of code come from an open source project that you consumed, 9 out of 10% of your technical debt is all external to you. So I go and I do security slams. We go out and I reach out to the most consumed Kubernetes projects, and we make sure that they are secure so that you can intake them securely, not make assumptions about the technical debt or security debt that you're intaking. If you have paid attention to the White House RFI, I am sort of theming all of this on this idea around memory safety. If you've read the RFI for memory safety from the White House, it kind of talks at you as if memory safety is a magic bullet, of which it is not. And memory safety is not the same across all memory safe languages. In fact, if I ever want to do anything fun in something like Rust, I have to go then work in quite literally what is called unsafe Rust, right? So understanding that all that we're doing if we're thinking about memory safety is really establishing design patterns that are clearly abstracted at the language level. Doesn't mean you don't have to understand them, okay? So in memory safe languages, the bugs are often able to be caught at compile time. It allows us to make sure that we're also not holding on to any extra memory. I'm gonna put this another way to you. If you do not understand memory safety yet, all that you have to know is that it allows me to build with a to prioritize occlusion, to prioritize not seeing, not accessing anything that I don't want to use, right? Design patterns, explicit design patterns. Now, applying category theory, and this talk is twice as long. I removed everything that literally has any references to explicit mathematics. We're gonna go to the highest level here. But applied category theory has been around for a good 50 years in the way that it's been intersecting with computer science. I think if you're in the Kubernetes space and you don't think about applied category theory, you just need to understand that applied category theory is the thing that is the reason why we have the first Paxos algorithm. That runs entirely on applied category theory and allows us to do our first fully parallel distribution computation. So it's been around. When I look at it in the Kubernetes space, I'm not the first person to think about it. There is a whole blog post on this asking you to go and frame your things in the TLA+, which you can if you want to. I don't think that's a very good use of your engineering time. I will give you examples of better ways to abstract what you're building and to represent it across your teams. So when I say turtles everywhere, right? We've got these ways of looking at our systems. You need to particularly be able to understand what level are we talking about, who needs to understand the information. C4 modeling, I'm going to go into detail on. But it's one of my favorite methods. And then secondarily, when I say this is really serious, when I'm working with an organization, we've got to get you all the way down to the level of having an explicit model that makes sure that I know exactly what is going on the second a 0-day hits, the second there's a cybersecurity concern. I need to be able to look at the system. Now what you're looking at right here, this is Argo CD. The complexity of this system, if you've got an SCOM that has 10 CNCF projects in it, take this, multiply it times 10, and then consider all the integration aspects to it. And as a cybersecurity engineer, that terrifies me because all that you think about, you don't think about this being Argo CD. You think about it as something that you execute. It's got concerns. I do have to say no longer because they graduated from CNCF last year, and both myself and particularly Control Plane worked with them to create a very, very good threat model. But the reason why I'm highlighting this is because I really like Threagile IO. It's a nice way of going through and scanning and getting literally this output. However, it's not been traditionally utilized in the Kubernetes space. It's a little bit better for sort of like Golang infrastructure. But I'd love to work with a couple of engineers to make sure we've got a really nice YAML format so that we could do this for every single CNCF project. Because right now, this model, every single CNCF project has a different threat model. I can't even tell you what the total surface area is. Quite literally. Computationally, I can't tell you. It's really concerning, the cybersecurity in cloud. So the whole point of applied category theories, right, is to study these fundamental and general abstract patterns that reappear. I have had to study applied category theory against my will over and over because it keeps coming up. It came up when I was doing signal processing and neuroscience and cybersecurity. And very recently, right, I was writing up this beautiful response on memory safety, saying, all right, here's the languages that you can transfer over to a memory safe to make it more secure. Here's the patterns. And then you go down, and I reread what I'd written to myself 5 years ago, and I go down to Haskell, and I was like, what are the problems here? It's like, if you want to deal with cybersecurity concerns in Haskell, quite literally, the only recommendation I wrote to myself 5 years ago was understand monads. I can't get you better than that. So, turtles all the way up. So turtles all the way down is a philosophical expression. You use it a lot to understand, like, can we actually get down to the base of, you know, are we all living on a turtle that's on a turtle that's sitting on elephants, right? We use this a lot when we want to talk about things that are sort of like hidden by APIs or hidden by occlusion. It's also the reason why we've got the cute cluster API logo. So I think I love this project making the choice to sort of like represent philosophy. So let's talk about C4 modeling. So C4 modeling has stages 4 to 1. You basically start with context and then you jump in and you jump in and you jump in. I'm going to show you how to do that working with your team. We've covered the threat modeling. All right, so what is a monad? I'm showing you a slide with absolutely 0 functors on it, 0 beautiful little arrows. But when I first explain category theory to anyone, I say, think about every time you've ever written an equation. Now replace that equal signs with an arrow only if you can guarantee that everything that happens from condition A to condition B within that set is valid, right? So you map onto data and the variations of the original structure onto another function composition. The laws of monads, I think what's so hard to understand is that the more you try to think and talk about monads, the less sense they make. So I really like to introduce these ideas and then to take you to a really practical and applied place, because all of you right now are having this reaction. You say, wow, this is complicated and I haven't seen anything applied yet to this category theory. And I'm very sorry about that. But here's the reality. I hired in this field, and it is impossible for me to find someone right now that has the exact skill set that I need. I can't even hire really good cybersecurity engineers in this generation because we do not train them to understand architecture, particularly in Kubernetes. You have never had to sit down and do an entire design pattern for what you're building. You just make assumptions about the compositionality of the projects that you're intaking. Now, if we are going to be asked to make sure that everything that we're building is memory safe, you can build memory unsafe conditions with memory safe languages. If you do not understand how to build rationally and with patterns, you're not going to be able to build anything that works with memory safety, and it definitely is going to cost you way more money than thinking something through. right? And so when I say we all want to be thinking as lispy thinkers, you don't actually have to write a Lisp to understand. You just have to start thinking, not like, I think sort of one of the things that I like and hate about object-oriented programming is that it's so easy, I think, for people to initially understand. And it's so hard to build anything efficient after that. I really wish people did not start with object-oriented programming when they started in software. But again, here's where we're looking, right? I'm in a situation where I'm being expected to build things that will not fail. I'm being expected to hire individuals that can build things that will not fail. And if I want to build the most perfect version of that, the only thing I can do now is ensure that every single individual on my team has some understanding of what they're building. Again, great for audit trails, you want these. I'm gonna skip over a lot of the facts around this because at the end of this, if you're really genuinely interested in learning and working with applied category theory, I'm going to be starting a sort of working group and reading group on this in 2024, specifically around cloud technology. So if you want to dive into this and do this in a real way, we can do that working together. So the last statement that I'm going to put out here is, right, are monads just fancy state machines? Yes and no. I think when you start to work in abstraction, one thing that's really, really helped me, and going back and like reading that Paxos paper really helped. What you want to do, if you want to understand state machines, I always try to think about, right, you have this little modular, right? You have real time, the real world, and then you have your state machine, and you have the world that you're representing, right? And if I'm taking in, right, I'm talking about taking in real world data on a Kubernetes project that tells me yes or no to firing something, right? So I'm bringing this information in, I'm trying to get the purity of the state out of my system. But what's really nice about these state machines is that you can just go and play with them. Just go and build a little simple state machine and understand that we're doing something different here. We're not just representing the system, we're representing a truth, a veracity. Hard to explain sans context, which is why I always try to take us into the most applied version here, but it's like calling a Ferrari a car. There's so much more that you can do, and it's so much more powerful if you are actually sitting down and not just making an I/O diagram, making sure that the math sitting underneath what you are trying to execute makes sense. Otherwise, I will talk to your SRE team. They'll have some things to say as well. Again, there's the identity monad, there's a maybe monad. I'm going to skip over those and just speak to 2 or 3 people in this room that still think that if you're doing object-oriented programming that you can't possibly think in this way. In fact, you do and you must, right? The fact is the builder pattern is instantiating a monad so that you can verify the connections between what you have just built. Okay, so now we're going to have fun. Because we've got about 15 minutes, and I just talked at you about just slides, and you're not going to remember any of the content on those slides, but you're going to have access to those and access to me. Happy to discuss with you. Here's something that you can actually do. So this is rapid prototyping. I learned this from Tom Chi. He was the technical lead behind the development of Google Glasses, which is not relevant because we all use Google Glasses, but relevant because it required him to think really quickly about how do you design with resources. So there's 2 things that are important here, right? We're going to maximize learning with minimum effort. We're going to do it as fast as possible. And we are going to give information an out-of-body experience. Number 2, hard rules here. Observable versus conjecture. Observable is anything that is directly seen as true, and conjecture is anything that we think is true or might be an opinion. It's terrifying when I go and I try to consult with a major organization, which may or may not be a bank that I use, and I get down to the diagrams that they would use when they have a cybersecurity concern, and it is conjecture. It has no relation to what they have currently have released. That's terrifying. So rapid prototyping. Say, I usually will recommend that you do this, 1, when you onboard a new team. 2, if you are setting up a new roadmap. Or 3, I usually do this 1 hour once at the beginning of every quarter, right? I do this process basically instead of Agile, and I'll explain to you why. So one, you're gonna set up the prototype goal. Typically for this, I'm gonna say what you wanna do is, I'm just gonna jump through these slides because I can show you this with C4 modeling and it's gonna make a lot of sense, all right? So C4 modeling, I use this, it was developed by Simon Brown, who was a real person I met last year. But I've been using this for the better part of a decade, and it allows you to see the context, containers, components, and code. This is very similar, although different from the 4 C's of cloud computing. Doesn't matter, it's just a way of thinking and communicating. So, what I want to do is have at the end of a sort of hour-long session, I'm going to start with the system context, which means I know who is intended to be utilizing my system and exactly what is that literally just context. I would also recommend that you do this for a malicious user as well, right? Do it for a hacker and see if there's anything that you see that looks different. Then what you want to do is move to the container diagram. Within each of these, do I actually know what the system is and how it's being called? Are there any fail-safes to it? And then number 3, right? Getting down, I need at the 3rd level, I need to be able to know exactly what the API call is. It doesn't take a lot of time to sit down, and if you do this on Structurizer, there's a free and a paid version. If you do this on Structurizer instead of doing it on like diagrams.io, you do this, you can actually tie it directly to what you are servicing. So this already, right? I have to work with teams. If they don't have this in place, I have to explain to them their #1 cybersecurity concern right now is operational, right? Because they don't even know where to start. Now, this is really interesting. The missing thing, the thing we don't have or hire for right now, solutions architects anymore. It just doesn't happen, which is scary because we need them, especially in Kubernetes. So I want you to think about taking on every element of these. So when we're going to start out, we're going to spend 20 minutes, we're going to take 3 minutes and say, all right, we want to do a context diagram of this part, right? So here, context diagram, solutions architect then says, all right, let's get the broadest model of this. I'm going to take this to my technical lead. Does the context diagram make sense? Technical lead is going to say, okay, the context diagram, when we step down before we build this, right? Either you're refactoring and you're looking at a system, but if you're starting from scratch, you get a chance here, instead of putting together a 6-month roadmap. I know the keynote today, I was just terrified because, yeah, you can't accurately know what you're going to be building in 6 months if you have not asked every member of your team in what way they would be contributing to that project, and if there are things that would fail. I had to start working in this way because 2017 Kubeflow, explaining to them that there are a couple of things that we just could not integrate, right? So level 1, system context diagram. I want you to think about going back, sitting down with your team, and saying, can we, in 20 minutes, put together the context diagram in a way that everybody agrees with? Now, the most important thing about all of these is the step where you sit and you talk to a, I'm going to take us back here. So, if you get on structurizer.com, spend a day with your Agile team, set up at least the context diagram. If you can get all the way down to those 4 levels, at any level of granularity, that's going to be really, really useful. But here's the trick. Here's the psychology trick about this that you must not get wrong. You can do this all, right? When you sit down and do Agile road mapping that doesn't end up being useful and takes 2 weeks out of the year, this takes an hour, 3 minutes to find the goal, get the context. Develop a solution model, make sure that it's written down, because the next thing that you're going to do is so important. That written down model is going to go to another team, another developer who did not just build that context, and they're going to have to tell you how your system works based on what you wrote down. If you do not have that, you are going to be hit by that developer bust, right? If the system is sitting in someone's head on your team, no one else is going to be able to execute, right? And it is not the answer to give everybody the pager. You just have to build the system in a way that's observable and communicable. So if they cannot communicate to you without you speaking to them about that diagram, you haven't made something which is useful, and it wasn't worth anyone's time. So if you want to do this rapid prototyping process, I say get a 20-minute timer, sit down and at least get the C4, the highest context. You can get all the way down to a sort of C3 and get the APIs. You're going to see an actual decrease in your MTTR. You should be able to see that. I've seen this in 4 different organizations. You're able to show that from Q1 to Q2, the instantiation of just basic common sense documentation that is directly, not representing, but directly tied to your architecture makes the biggest difference. It also turns every single individual on your team, from the juniors to the seniors, into some level of architect, giving them a skill set that no one teaches anymore. I cannot communicate this enough. We need these people to be able to think in this way. This is the book that I usually recommend to anyone who's in cloud computing, right? If every time I hire a junior engineer, I just throw this book out on their desk and I say, in 5 days, come back to me and you'll have most of the knowledge that you need, right? Understand metrics, process, integration. I have taken off of your fence functions, I'm not sure why. But I actually would really like to change the direction, right? So I've got a huge following of cloud engineers, and we're good, and we build interesting, cool things. But if I can get 20 or 30 specifically cloud engineers to work with me, read this. This book is great. I read like 6 or 7 Kubernetes books, and this is the one that I would actually recommend you start with, not even like the intro. This really well contextualizes it, and it keeps it in software. This, right? I need you to understand, right? Have we created a monad? Have we created a pattern? Like, can we literally identify the memory safe patterns which we intended to put in place? As we continue to move forward, these little tips and tricks of creating the observability of the logic of the executing system so that I can understand how to refactor it, one for cybersecurity concerns, but also just for efficiency. You can really, really see the difference between teams that work on deadlines trying to push out features and teams that every single individual is working on that core principle, that core roadmap. You see significantly less technical debt, and you also see, just circumstantially I can say they're just way more pleasant. It's way more pleasant if you teach your engineers that little extra context. If you give them 1 hour a week of going out and reading the category theory book, they're gonna keep working with you. They're gonna be happier because what you're doing is not using them like monkeys. You're using your engineers as what they want to be. They have gotten into this field because they're incredible problem solvers. They particularly enjoy problem solving and abstraction. If you do not use your personnel that way, you should not have hired them in the first place. Now, if you want to go and read some blogs or anything sort of around just starting to understand applied category theory, I really recommend this blog, but you also can't read anything on the internet about applied category theory without usually at least getting like a comment from Martos. Really good, really interesting and sound in sort of the developer principles that you can learn. So what we learned today, this was a really sort of chaotic talk on my side. I usually give, either strict tech talks or like cybersecurity talks. And this one, I wanted to step back and say, all right, cloud engineers, what am I missing? What can I literally not find on the CV or in anyone's work experience that's killing all of us? Like, it's killing, like when I'm saying banks, all of these major critical infrastructure, we don't have personnel sitting in these locations with any of the traditional skill set that we used to have when we a computer science degree. If we can get better at abstraction, we're going to be able to build systems that are significantly more efficient, but it works better to do this working with other teams and other infrastructures, right? Share the common knowledge, share the common patterns. We can get a repository, a basic list and understanding of memory safe patterns in cloud. You're in a much more secure place. I'm going to give you a couple of resources. These are absolutely non-exhaustive. These are just some really interesting resources. I think these two are good just generally to understand. I'm actually bringing up Rudra just because I was hoping if anybody has seen any more updates since 2023, but I don't think so. If you really want to follow up on this, I will be, throughout 2024, building out developer resources, figuring out, because I'm going to build basically the training that I need to create hires that I can't find. So again, if you're interested in this and you would be interested in one, testing out how to make, like if you have not built a threat model before, right? I'd be happy to work with you on figuring out how to build a verifiable threat model. I'd love to work with you. Again, Agile is an open source project. If we want to get anything done there, it's going to happen from our fingers on our own keyboards. But all it's going to take is refactoring a YAML file to get a much better way of getting a standard model across all, at least CNCF projects, but I'm happy to see this across all cloud. Okay, so go forth and learn with me, technical leads, join me, and we'll do a memory safety reading group. It's going to be another slide after this so you can get in touch with me. DevOps and feature engineers, work on C4 modeling, cybersecurity and site reliability engineers, I want to work with you for Threagile, because Threagile is just as useful to SRE. And for the final page, right? Reach out to me on LinkedIn. I have it on the connect thing, so you've got to reach in and find me and add me, or just send me a message. These are the things that I'm going to be working on over the next year. So I came here today to talk to you cloud engineers about this crazy but not so crazy concept. One thing that you can do is use this C4 modeling and specifically rapid prototyping, externalize everything that you utilize to observe your system. And to start working like you are both cybersecurity and an SRE and a DevOps engineer and somehow a front-end engineer, because that's what we all are. And you gotta have the skill set to do it. So I'll stop there, and are there any questions? Or anyone who's particularly excited about joining my reading group? That's fine, the closure people will come. Anything else? Go for it.
So many systems nowadays, you find the architects, so in so many systems nowadays, you find architects who aren't actually necessarily building stuff, but they're assembling. There we go. So I was saying, so many architects nowadays aren't actually necessarily building stuff or designing new stuff, but they're assembling stuff that already exists, right? And I kind of wonder, how much does this need to percolate down in the organization and in the way people work, and how much of this needs to be applied to the components that people are building with to make sure that those components themselves are some sort of de facto safe in some way? And I kind of fully get the concept that you can completely do unsafe things with things which are supposed to be safe, right? But ultimately, can you get it down to every level in the organization? Does it require a super evangelist like yourself?
Well, yeah. So when I step into work with organizations, quite honestly, that structurizer, sometimes I'll come in and if they can't, I have a break in my contract which they cannot build that diagram. I can't give you cybersecurity operations. You don't know your tail from your head, right? But no, I think the thing that's specifically missing in understanding, and you don't see this even for think about the alternative persona, right? Just off of you is the Rust engineer right now, right? You typically work with the Rust engineer and understand more about build patterns. They're more likely to open up and look into the thing that they're installing, right? They're more likely to see, are there patterns, is there going to be an interaction here? And increasingly the problem is, right, when we're dealing with just this persona, this is a platform engineer, platform-oriented engineer, right? The problem is that what you've done is just completely obliterated your ability to understand what you've created. And that is why I wish on the security side people could really understand. I have to look at this at that language level because hackers are looking at it at that level. It is amazingly easy to exploit Kubernetes right now because of course, I'm gonna go, right? When I say trying to protect things like Argo CD, every time there's a security error in Argo CD, right? You got hundreds of thousands of effects on that, right? If they capture it, they even see that there's been a security vulnerability that's been patched, right? I think best engineers, they're still going to be high-skill engineers. They're getting development patterns. They're understanding it somewhat, but I'm also seeing this element of right, the way that that memory safety RFI was written, didn't understand, right? It was quite literally someone who's never built a thing. And increasingly, none of you ever build a thing, right? You just intake it.
Sorry, I don't want to monopolize the conversation, but you know, one of the things that I'd love your input on is how important is the security of the component versus the securities on the interactions of the platform? Because nowadays, you know, like 20 years ago, you would figure out how to make each individual component secure, and the component was the monolith, and that was the thing. Nowadays, you put in a bit of YAML, and it spits out 50 containers and automatically puts certificates in and connects things up together and puts in multiple levels of abstractions and virtualizations. Like I don't think anybody has the ability to know anymore.
Yeah.
The platform knows. It's almost like the machine learning question as to, you know, how do you know when the source code is compromised?
Yeah, 100%. This is really the problem, and the way that it's a completely fixable problem, first of all. This is a fixable problem. We're just at a stage, quite honestly, we're at a really interesting, weird stage where there hasn't been a standardization of abstraction. We just now are building up the tools to be able to do that. It's incredibly important. So it's not just that you can intake vulnerabilities, right? It is the fact that when I'm trying to build things like Threadfile, when I'm trying to work with SBOMs that are machine readable, what I'm trying to do is, yes, see that, what I would call a composite vulnerability, right? So like log4j, log4shell, composite vulnerability, right? Not a problem unless you also have JNDM, right? So there's way more of those, and those are much more likely to be, I mean, that's what hackers are exploiting right now because we don't have the scanning tools in order to stop that. Now, if I can get, this is why I'm so serious about getting a subset of engineers to help and standardize literally just scanning for threat modeling. I need those threat models to look the same on the back end of every CNCF project I bring in, or that threat model was useless to me, and I have to build it again myself, right? We wasted hours from not doing this with real and verified abstraction. When I say abstraction, I'm not saying get away from the truth and the logic, I'm saying only represent the truth and the logic. But yeah, if we don't fix that, you're going to keep seeing, in specifically Kubernetes, it's just going to continue to exploit those like multiplex vulnerabilities. Because they're easy to exploit. They're really easy for me as a hacker to find. No one is incentivized to scan or fix for those, unless, you know, things blow up like log4shell, which there are lots of issues that go like that but just don't get the marketing. So.
How do you access the slides? How would you access the slides?
Access the slides? Not from that one. It is all the way at the front. 1 second. So I actually have a, there, that's, oh gosh, that one. I actually have a much better talk on rapid prototyping from about 5-6 years ago from ClojureCon. So if you want to go back and think about that 20-minute sections, all I can tell you is that I introduced rapid prototyping and C4 modeling into organizations, and they add down and export. They're all happy, they're all working, they know what they're working on for the first time in years. Cool. There's probably more questions. I would be happy to be in touch with everyone, but this was very much a opening up a conversation kind of talk. So.